This talk is about injecting electromagnetic pulses into digital devices. And I'll tell you how I got started working on this. NASA publishes a post-mortem on airplane difficulties with electronic devices. And what they didn't realize is basically they're giving somebody a roadmap to build a device to create so much interference that they could bring the plane down. And I have a number of these NASA things that I've been able to take off of the internet. They don't seem to do it today, and I'm not sure why. It may be they realize that these things could be used for other purposes. I'm really not sure. Anyway. Okay, in this talk I have some foils, about 27 PowerPoint slides. The slides really, they're okay, but they don't really tell you anything. They don't tell you much. I have 9 videos. The videos, you come away from here seeing the videos, the plane, sleeping on the plane, you get up tomorrow morning, you'll remember the videos. That'll create a big impact. I was supposed to have 10. The 10th video was actually my pulsing a Pentium 166 megahertz laptop, an old laptop, and the hard drive I already fried. And I pulse it, and I boot it up over Windows 95 diskette. I'm pulsing it, and it stops. It dies. It needs manual intervention. So I stop it, I bring it up, and I use a Red Hat Linux boot disk. Pulse it, it stops. Basically what that shows is that if you inject electromagnetic pulses into digital devices, they react with irrespective of the operating system, actually irrespective to some degree with respect to the actually the CPU, but they do disrupt the device. I'm going to show the first video here, and that's a Spark app. And you see it disrupting this dumb digital device. Why do I say it's dumb? It's dumb because it continues working even though I'm pulsing it. Smart digital devices do one of 3 things. They stop, they freeze, they need manual intervention, they try to reboot, or they turn themselves off. Obviously, I haven't tested every single device in the whole world. How I came up with that is just reviewing literature on the internet. Anything I get my hands on, that's what I've come up with. You have dumb digital devices, you have smart digital devices. The other thing about dumb digital devices, not only this calculator, they're also standalone type of analog detectors. A standalone detector could be on a pipeline, something else. It could be a pressure detector, a temperature sensor, a pH sensor, a voltage sensor, something else that produces an analog output. And then this output is digitized onto a network and is fed into, let's say, a supervisor control and data acquisition system. And I'll talk about a little bit more about that. The pulse is created here by Mark's generator, and I have a video, even though I talked about the Mark's generator, I have a video showing you the actual components, the charging circuit, all the good stuff. So that'll be there. I'll step along with the talk and the videos, and again, the videos are important. You'll learn more from the videos. You'll be more impressed with the videos than the foils. I'm talking about the history of EMP. The Starfish. Starfish was a atom bomb explode. Actually, I think it was a hydrogen bomb that exploded in '63. It caused a number of outages in Hawaii, and that was how the big thing about electromagnetic pulses came about. Mark's generator. I'll explain the Mark's generator. I have a video for that. Pulse parameters. Not all pulses are the same. There's a number of parameters that define the type of pulse, and you can actually pulse things where it's innocuous to digital devices. Dumb devices, smart devices, Byzantine faults. A Byzantine fault is if you have a large distributive system, and increasingly everything is a large distributive system. Let's say you have 100 components. How do you know you're getting the accurate information from all these components, and how can you formulate an end result? supervising, control, and data acquisition. Hospitals are very electromagnetic pulse susceptible. Today, tremendous productivity of the hospitals. It depends upon devices monitoring. EMP, processor and operating system independent. The Green Revolution, fly-by-wire, TW800, and in there I have a video of a throwaway camera with a strobe. And I take it apart, and I use the equations to figure out how many joules of energy it is, and to see whether or not it's possible to have created the spark for TW Flight 800. I'll talk about 800 a little bit more. This is just a formula for power in joules. If you had to figure out the power in joules coming from, let's say, a Marx generator or just from a capacitor. I talk about the power grid. Something that I came across is that you can take the power grid, the national power grid, down by injecting pulses into it. And this is not so much, this is more physics than anything else. The power grid has been taken down before because of magnetic disturbances from the sun, magnetic storms. To power these devices that I'm talking about, I would not use a Marx generator, I'd use a Tesla coil. One of the original Tesla coils that Tesla built in Boulder, Colorado, he actually brought the AC generators from the power station down. So there's a lot of historical data that you can put together and say, yeah, you can inject pulses into a grid, bring it down. Not only bring it down, like as a power blackout, bring it down as a power outage. In other words, you could destroy equipment that you don't have the outage for a day or 2 days. You may have it for weeks. And I talk a little bit about Tesla coil and also power quality. The grid is almost a living being where you have to maintain homeostasis constantly. Okay. History of EMP. The Compton effect, the H-bomb. You create it also with Tesla coils. Not so, Tesla coil is more electromagnetic interference, but you can create pulses with a Tesla coil easily. Marx generator, that's what I use. Explosive device, armatures. That is more of a military device that you charge this armature, and then you explode this armature with high explosives, and it creates a pulse. We're not going to do anything with that. Okay. The H-bomb, Starfish, 1962. U.S. exploded an H-bomb 800 miles from Oahu, Hawaii. 30 strings of street lights went out, 300 street lights in all. That was the first when there was this notice that you can create pulses and they can bring down electrical systems. The Marx generator, and everything that you see on the videos is powered by a Marx generator. Invented in 1924, it's just a concept now to create high voltage. Capacitors are charged in parallel, capacitors are discharged in series. Now we're going to have another video showing a Marx generator and a charging circuit. The orange things are capacitors, and they're in parallel. They're being charged in parallel. And you see the rails that they're charging from are resistors. This is off-the-shelf type components. Off-the-shelf components do not like to work in a Marx generator very long. You end up burning them out rapidly. If you want to build right now I'm showing you a wire that they discharge through. They discharge in series. If each capacitor, I have, what would I have, 5, 6? Well, let's say I've set 5. If each capacitor charges to 5,000 volts, and I have 5 of them, I have 25,000 volts in series. And it's discharged through this spark gap, which you already saw before. Just PVC pipe, 2 conductors. The thing about my Marx generator that is different from everybody else's generator is that I optimize an extremely high pulse rate. Not a high voltage, but a high pulse rate. Now I'm showing you some analog meters. An analog meter is an analog meter. There's no electronics. It's good to keep an eye on what's happening in your generator. Now I'm showing you a control circuit for an integrated circuit called a 555 timer millions of references on the internet. You put in Yahoo, Google, whatever, millions of references. It creates a pulse, and it's fed into this thing called a MOSFET, a type of power transistor. It sends its pulse to that green wire. The green wire is attached to the gate of the MOSFET, turns the gate on and off. In other words, I put high voltage, battery voltage across this transformer. Specialized transformer, it's a flyback transformer. These are transformers used in TV sets, cathode ray TV sets, plus high voltage. I purchased flyback transformers just off the internet and other places. I've also gotten flyback transformers for old TV sets. The old TV sets always seem to work better. I don't know why. Okay, that's it. If anybody wants me to repeat any of the videos or anything else, I'll do it. This is another type of Marx generator. This is a little different. The spark gap is actually inside of this PVC pipe. The capacitors on the outside, the silver things, and then they have a resistor on the rail. When you start creating voltage sparks, high voltage sparks, they start to increase intensity in terms of dB intensity. 120 decibels, it could be over 130 decibels. The pipe is basically to muffle them, putting muffling in there. And that was more of a specialized version that I had to do because my Marx generator was setting off some type of alarm in buildings. Let's go back to... Okay, that finishes the Marx generator. Pulse injecting. You can inject these pulses. I haven't shown it yet. You can inject them any type of electrical wiring. The difference between creating a pulse in free air, and that's what I've done and shown you that dumb device, and the difference between injecting into wiring. Free air, the pulse drops off as 1 over R squared. If I'm 1 foot away from the spark gap, and then I move 2 feet away from the spark gap, it drops off by 1 over 2 squared. In other words, at 2 feet, it's 1/4 as high, the value. If you inject electrical wiring, which could be any of these wiring here, it basically becomes an LCR circuit, an inductance, capacitance, resistance equivalent. But it travels for many, many meters, many, many hundreds of meters. Again, it's very destructive when you do inject it into pulse, into any type of wiring, or even, again, grounding. Dumb digital devices, simple digital devices, they keep on working after being pulsed. Standalone sensors like scatter, temperature, pressure, voltage. You're actually doing a type of EMP fuzzing on the device. The device is dumb. It's going to just pick up the pulse and send out any type of value at all. Again, if it's some type of pipeline where it's sending out an erroneous value of pressure or temperature, whatever else, and this is going back to a computer where it's figuring out some dynamics of the system, then that could be a problem. I mean, it depends on what type of edits in the program. I mean, you just cannot beforehand figure out what would happen. Smart devices, again, they reboot. They need some operator to manually reset them. They turn themselves off. Again, surveying all the literature I can get my hands on, laboratories that have these devices, what happens to these devices inadvertently, putting it all together. Again, they do one of these 3 things. And I got, again, the spark gap there, and I have a TI calculator, and smart devices are generally much more susceptible to a pulse. Like I'm trying to put numbers in, and I can't even get it close enough that I could keep the number in. I tried even moving it back, but I just, it keeps shutting off. I just cannot get it to. The one other thing about smart devices is that they do have a memory. Qualitatively, I observed that smart devices, when you pulse them, you do cut down the life of them. In other words, if this device would normally work 5 years and you start pulsing it, it may only work 1 year. And I did find literature that validated what I was, able to observe. So, it was a real event. If you're injecting these pulses into a network, it could be through network wires, or you're better off through the electrical system. The ground seems to be the best choice because the ground goes every place. And even though you might say, well, this wire is grounded into a grounding cable into the ground. Well, that grounding cable going into the ground has a much higher resistance than the electrical conductivity of the rest of the ground, so it's not a big deal. As long as you keep injecting these pulses, somebody cannot, if it's a network, bring up the network, or you're going to have different devices doing different things. Turning off, need to reset, trying to reboot. As long as you keep doing it, you create a problem for them. Again, it's invariant with respect to operating system, to some degree, and that's a special case, architecture, electrical architecture, but the device will have a problem. Moore's law, we all know it's Moore's law, that number of transistors basically doubles every 18 months. As the die size decreases and the electrical voltage that you need for the CPU decreases, you make them much, much, much more susceptible to pulses. Significantly more susceptible. So again, we're making devices that are more susceptible, and we're building more smart and green devices which use, again, more solid-state devices. I can't stress this anymore, that not all EMP pulses are the same. You have to basically build a design EMP pulse that experimentally is very detrimental to any type of electronics, solid-state electronics. Again, you're going after the transistors, the integrated, so you're not going after the resistors or capacitors because you would need a significantly higher power level for that, and you don't have to do it. I mean, you just go after the intelligence. You really don't have to go after anything else. The pulse width, the pulse rise time, the pulse rate, how many pulses per minute or second, harmonics. Harmonics are very, very important. You want something extremely harmonic rich. Frequency, contrary to what most people think, that if you use microwaves to disable a device, actually they seem to be much more susceptible for under 10 megahertz. And I don't have references in here. I should have put it, but there's references from something known as the Old Crows. It's something done in Australia, and that was the only reference which validated what experimentally I observed. Byzantine faults. They're large real-time distributed systems. Byzantine fault tolerance and recovery. As number of processes. T is number of corrupted processes. This is only possible if n is greater than 3t plus 1. It basically works out that if you have 100 devices and more than a third of them are giving you erroneous readings, you have a serious problem. This comes more into effect if you have a serious real-time systems, fly-by-wire, any type of real-time process control, chemical process control, where there's a real issue with just correct computing. This video is not very... you see me plugging this 3-prong adapter. I'm connecting a wire to it, then I'm going to plug it into a 3-prong adapter into an outlet, connect to a metal box. And the wire, I'm going to connect to one part of my spark gap. This is basically proof of concepts that you can inject these pulses into wires. Unfortunately, this video is not that good, but at the end you will see that I'm injecting this pulse. And let me try to... Okay. I'm still doing it. I'm just had to get my wife to take the video camera. What I was trying to do was video everything by holding the camera in my hand while I was doing it. The problem is I had a Sony video camera, and the Sony video camera did not want to be that close to things that were being pulsed. I had problems with it. It did not want to be that close. Probably I aged the video camera too. I don't know how much. She's got to zoom in more. I guess you really can't see it. Well, now can you see it? Can you see the numbers appearing and disappearing? You can, okay. This is just like more of a proof of concept that you can inject pulses into conductors or into the electric grid if you want to disable that. It has a metal box because I live in New York City. New York City has a very strict housing code because, you live on top of each other. And they don't use plastic boxes there, even for residential construction. There has to be a metal box. Supervising, control, and data acquisition. Again, large real-time distributed systems. Controls chemical, water, oil, power systems, the grid. Large mix of smart and dumb devices. Again, you have fuzzing of dumb devices. Fuzzing of dumb device, again, you're getting erroneous readings. And whatever edits that are actually in the programs, however it responds. Going green buses, solid-state controls, green cars, everything that we go as we try to go green or smart, it's vulnerable. Robotic trains. The DC Metro train is actually a robotic train. It's a train that it has an operator, and it has a communication system that communicates where it is with respect to other trains on the system. And there was a recent crash of it. The L train in New York City is also going with the same system. There's a problem in that the third rail shoes arc. I don't know if you've taken subway systems or subway systems in New York City where the third rails arc. When they arc, they generate a pulse into the system. And even if the electronics is protected with pulse compensating materials or whatever else, if it's injected into the electrical system, there's not too much you can do about it. There's not really a way that you can adequately filter that. I have another video here that I'm injecting the pulses into a pulse, actually a surge protector. I covered all the names. I'm not really using the surge protector correctly as it should be used, but I have the surge protector there. And look, if you're going to create malicious pulses, malicious electromagnetic interference, there's nothing that on the market you're going to buy that's going to stop somebody from pulsing. If they know what they're doing, if they know the frequency spectrum or how to create it, they will create a problem for you. And I turn the Mux generator on, and you see 0 in there. And as I move it, you see whatever else. And it's not pretty. I mean, hospitals especially would be very susceptible to this type of attack. And again, you could either inject it in the basement of the hospital, you inject some of the outlets, the grounding. The grounding wire is one of the best places to inject it. Fly-by-wire. Actually, this is the thing that got me interested in this, the work that NASA was doing in electrical interference with controls in a commercial jet. And fly-by-wire seemed like they were just going in the wrong direction. They're making the machines too smart and too susceptible. There's two different versions of fly-by-wire. The Boeing version is the pilot is always in control. The Airbus version is the computer is in control. There's a small envelope that the pilot can actually maneuver his jet through. My prediction with that is that would be a major disaster running Airbus. Boeing is, in my opinion, the better way to go. Again, fly-by-wire, advanced computer systems. A lot of the devices have different operating systems, somewhat different network protocols. They try to make it as safe as possible. They were thinking of virus, worm independence, that somebody could upload it. But it doesn't matter. If you inject a pulse through it, you're going to bring it down. You can't inject a pulse externally to an airframe. The airframe acts as a type of Faraday shield and just goes around it. Airplanes have been hit by lightning many times. They've gone through very high radar fields with no problems. If you go to the laboratory and inject it into the electrical system or even into the internal metal superstructure, it will cause serious problems. I haven't done it, but I know it will create problems. Actually, I'm not going to do it on a plane that I'm on either. So, but if people fly planes into buildings and do other things like that, the TSA is not going to tell them it's a Marx generator and charging circuit. They're not going to say what the hell do they know? I mean, they're looking for explosives. They're looking for doing things the old-fashioned way, and you're doing things the new-fashioned way. The TWA Flight 800, it went down in Long Island Sound, and they didn't really know what happened. Some people said it was a rocket. The official version is they had a center fuel tank explosion. If you created a pulse, if you injected pulses into an airplane, and let's say you brought it down, it would also have an effect on the black box and the solid-state memory that records all the flight information. The audio tape, magnetic tape of the pilot conversation, it probably wouldn't have too much of an effect, but it'll have some effect. So, like the artifact that you would find is that some type of, on the solid side, you would use some type of pulse, dampening pulse, or you might just find the memory erased. Okay. What I have now is. Hopefully I have the right video there. Yeah, this is a disposable camera. And before, when I spoke about the Flight TWA 800, I said that it took independent experimenters experimented with a 737 center fuel tank. And they pulsed it and they injected up to 75 millijoules. And they found that 75 millijoules, this center tank exploded. All these disposable devices contain pulse devices. Took it apart, measured the capacitance, measured the voltage that it'll charge, and I don't know if you see too well, but I'm charging it up. I don't have the video turned on, but I'm charging it up, and it charges about 300 volts. And I measured the capacitance at 100, well, it's on the next screen, but 100 microfarads, I think. I remember what I did. When I go to short it out, again, I don't have you hear a big spark, and I have a probe that I'm going to short it out, and you see me jump because it is quite a whopper. I've gotten burned more on these than I have gotten burned on Marx generators or anything else. Yeah, that's why. No, I mean, it really is a loud, these pulses produce loud noises. Industrial labs where they do generate large pulses, high voltage pulses, usually with earmuffs. You will get over 130 decibels, which will hurt your ears. Okay. Here I'm giving you the formula on the power in joules. C is the capacitance, V voltage. I did that measured at 102 microfarads. The voltage is 300 volts. And it comes out to approximately 4.5 joules. So a little camera like this still has enough potential to explode a fuel tank in a jet. The Air France that just recently went down, they didn't recover the black box. It would have been interesting. I know that groups that are working on pulses and possibly using their airplanes or jets, Chechens, from just information I've been able to put together from different blogs. I know Chechens are working on it. I don't know of any other group that's working on it. Certainly not any Arab group that I've come across. But that Air France was an interesting story, and I hope they recover the black box. I'd like to see if they did find any type of ringing. The other thing is that if, let's say, you pulse one of these fly-by-wire airplanes, what do you think would happen? My guess is that the jet would make violent movements, and maybe the tail of the wings would come off, and it basically would crash down from there. It's almost like Apollo 13. That Apollo 13 was the Apollo flight that the air tank, the oxygen tank, exploded on, and it caused it to go out of control. The thing is that there's no atmosphere in space, so even though it was making violent maneuvers, it was not breaking apart. And again, the telemetry and everything else, they couldn't really put together what happened until they reworked, took pictures of the damaged craft, and figured out what happened. Hospitals are very microprocessor rich. Hospitals are probably the most microprocessor rich of any type of entity that we have here, aside from, that's a fly-by-wire plane. You have ventilators, you have patient monitoring, you have a combination of dumb devices, smart devices. Again, if you start injecting pulses into the electrical system, they would not be able to restart or try to reboot everything at one time. And if the patient was actually on a ventilator or heart-lung machine, they'd probably pass away. That's probably something more for somebody who is an extortionist would try. The power grid. Next year at DEF CON 18, I'm going to do a full talk on the power grid, how it works. I'm talking about AC power grid, how it works. It's basically a living type of entity. It has to maintain a type of homeostasis. The frequency between generators has to be tightly monitored. The reactance, the capacitance, the transients, any type of a wave that's occurring in the grid has to be dampened out. In the United States, we have three major power grids. We have the East Grid, the West Grid, and the Texas Grid. From the type of attack that I'm talking about, the Texas Grid is independent of anything like what I'm talking about an attack. It's independent because it's not coupled to the other grids through AC power lines. It's coupled through direct current power lines. So if I tried to inject pulses into the grid, it probably wouldn't have an effect on that. It might have effect on the high voltage rectifiers that rectify the AC going into the DC for Texas. I'm not sure. Again, we have a high voltage AC grid. We have high voltage DC grids. Power quality. Power quality is very important. Inductance happens from an inductor, a wire wrapped around some type of ferromagnetic material. Capacitor, stores up charge. Harmonics are very important in the system. The frequency stability, very important. The video that Homeland Security did showing that generator that was actually burnt up. They said somebody hacked into the supervisor control and data acquisition system. The generator was a diesel generator. They ran it, let's say at 58 hertz on a 60 hertz system, and it destroyed itself. Transients again. The gadget, I think you could bring the grid down with about 20 to 30 different gadgets. Probably cost between $25,000 and $35,000. About 60% of it would be based on a Tesla coil. You can create it using a solid-state devices, MOSFET, IGBT. You also create it using tubes. The 833A vacuum tube is a big monster tube. The positive thing about using a tube is tubes and electromechanical devices are immune to pulses. In other words, you could run it and it won't destroy anything. If you create it using solid-state devices, eventually they'll die. Eventually you'll have enough power reflected back from the grid into it, and it will destroy it. Grid stresses. The grid actually has a number of stresses. A new network worm could be a stress for the grid. New Windows viruses. The Microsoft change cycle. Hot weather. Injecting pulses into the grid. The time of day, 5 p.m., is a good time for the grid to have a power blackout. Winter, summer, that again is a high stressor for the grid. Again, break down North American power grid, 20, 30 devices, distributed over weak nodes. There are actually weak nodes in the grid, where these nodes, if these nodes fail, other nodes will come down. It will have a cascading effect. There's some nodes that are not weak at all. They're relatively strong. There's some nodes where a lot of power goes through them, interconnected with other regions, and they have a high failure rate. You're just basically pushing it over the edge. And again, this is a system that has to maintain homeostasis, a system that is really always in a metastable state. It can be at any one time disturbed from that state. Each device would have to be tuned. This is very doable. Although I don't know anybody who's done it yet. And let me show you the last, I think it's the last one, is it? This is my kilowatt meter that I have down there. And I didn't intentionally post it or anything else. And it's plugged into the power. My digital meter is reading 126 volts, and this is reading like 201, 208. And just pressing different power buttons, it's indicating totally erroneous results. This was not intentional. This was in the general area where I was doing things, and this was about 10 feet away from everything. And I was very surprised. I would have taken farther away. Actually, my Sony video camera, I probably should have done something different with it, because it did have a lot of hiccups when I was doing videos. But again, this is, defective now. And I guess I'll have to order another one and be a lot more careful. DEFCON 18, I'm going to do a talk on how the power grid works. Most of this information is readily available on the internet. I'm putting it together, and much more detailed. And I will put together, either I will build a device that I believe I can take the grid down with, or at least talk about it. Tesla coil is easy to build. The other things that I have to add on to it are much more difficult. And I work by myself, and I have my own limited funds. But it's very doable. Again, one of Tesla's bigger coils up in Boulder, Colorado, took down the electric power, AC powerhouse that was powering it. Magnetic storms have also taken down parts of the grid. So it's just a question that instead of an external source, I'm injecting pulses directly into it. Okay? That's it for now. And I probably finished early. So, and instead of going to the other room, does anybody have any questions? I guess not. One other thing that this information is readily available on the internet. I mean, you can build your own device. There may be better sources than I'd rather people build their own devices and show it to me next year, and this way I could learn something from them. But this is all readily available. The Marx generator, the power to charging circuit, everything. One interesting thing is that if you do bring down the power grid, as I said, this is not going to be a power blackout. This is going to be power outage, because you're actually destroying equipment on the grid. When you start injecting pulses, the first thing to go down will be the supervisory control and data acquisition system that monitors the grid. In other words, they will not know what voltages, what lines are up, or whatever else. They will start going down. Yes? What? I have no idea if somebody's creating to write a pulse. I could create a generic pulse and pulse something and it'll have no effect. I can create a pulse. And again, I said the pulse parameters are very important. There's not one pulse that will bring it down. There's certain pulse rate, harmonics, frequency range, power range that you really need. One other thing is that I'm also doing a longer-term study of New York City. What happens if the power goes down for an extended period of time? And I'm talking about a week, over 3 days to a week. And believe it or not, one of the first problems you're going to have in New York City is a cholera epidemic. The reason being is that New York City, most people live in apartment buildings. The water actually has to be pumped up to a top tank, a wooden tank on the top of the building to provide water for everybody. We have a gravity-fed system that only goes about 2 or 3 stories. Sorry, go ahead. Yeah. Yeah, you can protect it, but if they're grounded into the same system that I'm pulsing into, it's not going to help you. Like I'm basically talking about using the ground. I found the ground is the best thing. It is like an open invitation to go into a device. Yes?
What do you find is the optimum pulse rate?
As high as possible.
Fast.
Yes.
And why do you find Tesla to be better than Marx?
There are problems when you create a Marx generator. There are problems that you have when you create higher voltages. That the air field, the air AIR breaks down, the electric strength breaks down. And also, I felt that for what I need, the Tesla coil will be more controllable. Because I'm talking about creating anywhere from 100,000 volts to more. But I'm also going to pulse it. I'm not going to continuously feed it into the grid. This is all experiential. This is, what I've observed and what I think will work. Go ahead. No, I haven't. Interestingly enough, the cable box, I demonstrated the cable box, right? Did I? Oh, I did. Okay. The cable box is almost all metal. And I also found another thing that I've tested some other things that the box was all metal. And I would think that it acts as a Faraday gauge. And I found I was able to pulse it and bring it down. The only thought I can have is I must have injected enough of a energized charge into the external shell that it re-radiated the charge internally and externally, and it brought the CPU down. So in other words, the Faraday shields may not be they may have been tested in such a limited way that if somebody's trying to create destructive pulses and does a wide range of experiments, they may find that these Faraday shields do not hold. I hope that answers the question. Yes? It's difficult because the power grid is very parallel. They actually have a grid, a wiring, so that if one set of feeders burn out, other feeders will take over. You probably localize them in some area, but like New York City, I'd say that I need about 5 or 6 machines. So you probably locate them, or they're in Brooklyn, or they're in Queens, Northern Queens, or Bronx, or whatever else. I don't think you do much closer than that. Basically, this is like the internet. Nobody thinks of the power grid as being something that you can exploit. You just plug things in, and nobody thinks that, hey, maybe somebody could inject something in there to create damage. By the way, if you inject these pulses to the power grid, you're taking down all your neighbors and all the other people's devices too. That's the other effect. I'm sorry. First of all, if it's wireless, the pulses fall off as 1 over r squared. They fall off very rapidly. What I've found is that if I'm pulsing something, and let's say in my house I have beams that are both wood and metal, the metal also becomes a conductor, and the metal, it also travels. I found that there's a high issue of fratricide. In other words, you're burning a lot of other things out inadvertently, like that kilowatt meter. And again, my Sony video cam, I hope it's going to last. But it really did not like this. And I was actually shielding it with my body. My body was not that effective. Anybody else? Yeah.
What about pulse rate? They're about IGBTs.
Yeah.
They do high pulse rates, typically break down around 15 or 18 kilohertz.
Mm-hmm.
So what do you pulse it?
If I use it for a Tesla coil, I would not try to control the pulse rate through the coil itself. I try to control the pulse rate through some type of mechanical device that is basically arced. In other words, some type of rotating device or something of that nature. So I would not have the Tesla coil continuously arcing out. Solid-state devices are a big problem. I'm not sure how I'm going to do this. I'm probably going to have to go with the vacuum tubes. Just so that, because solid-state devices, they're going to fail, and I don't know when they're going to fail. And by the way, if you do this, I talked about MOSFETs, power transistors, 555 timers. Buy a whole load of them, because you're going to start. Things are going to go down on you just like that. You're not going to. Also use batteries. Don't use a power supply, an electric power supply, or a regulated power supply, because that power supply is going to go down. What happens is that unless you have the impedance matched up perfectly, part of that pulse is being reflected back at your equipment and into the 110 wiring of your building. Use batteries, period. I guess I didn't answer your question, but the solid-state device, I would not try to control through that. I try through a mechanical type of switch. I'm not sure yet. I know it will work. The trouble is that I don't know how to test it. I don't have a test environment that I can test it in. And I do know people who do build Tesla coils for a hobby. And I do know of cases where they arced over into the cable system and the electrical system. And what's happened is that they did take down a lot of infrastructure. But generally the cable company, I know the cable company, electrical company, they ascribe to some type of fake lightning, some type of strange lightning. So usually if that arc over happens, you're going to be very quiet about it. I mean, if you have an arc over and let's say there's a hospital nearby, they're going to get some type of pulse. And you don't want people from the power company or the cable company wanting to sue you or sue your homeowner's insurance, because this happens. And if you do go to some of these Tesla meets and everything else, you will hear some anecdotal stories. Nobody say, yeah, it happened with my coil, because, it's always ascribed to some type of rare lightning. Because the engineers at the other end, they don't realize this happens. I'm sorry, go ahead. Yes? How does this work at digital locks? I don't know. My guess is a digital lock is probably a small device and it would fail. It would go into failure mode where it would lock. That's my guess. I haven't tested it. Anyone else? I think the question was, what happens when lightning strikes a power line? First of all, they have lightning poles on stations where they have, let's say, they're bringing a 138 kilovolt line in. They have long poles so that if lightning's going to strike, it strikes the pole. There are also lightning arresters. There are a number of devices. You cannot, with this Tesla coil, you cannot automatically put 1,000,000 volts into the grid, because what you'll just do is arc over. You would basically have to sneak up with the voltage and the pulse rate. Because the first thing that you want to do is take down the supervising control data acquisition systems, which is the weakest, and that'll go down. Transformers will ultimately go down. What will happen is you have a step-down transformer, but on the low side, the low power side, you put in high voltage. So that's being stepped up tremendously on the other side. But what will happen is these transformers, these pole pigs, is that you'll eventually break down the insulation, and you'll have a capacitance also type of effect where you'll still be inducing enough of a pulse into the wiring. Anyone else? I think the question was, couldn't you harden the supervisory control and data acquisition systems? I don't think so, because I don't think that this is an attack that anybody on the drawing board ever thought of. I could be wrong, but there is data out there where these grids have had problems with man-made and also natural sources. Anybody else? I don't know. I don't think they can. Well, okay, how do you think you could defend against it? Do you have an idea? I don't think so, because this is like an attack that's coming from a vector or methodology that nobody's thought of before. Although I did run this by some people with PhDs in physics and electrical engineering, and they wondered why, wow, I'm surprised nobody ever had that idea before. I mean, you can make a lot of money as a terrorist or go into well, this is very asymmetric. I mean, for about $50,000, you could build a lot of these devices, and you could take down a multi-trillion-dollar economy like the United States. And as I said, if New York City doesn't have power, there's no water in the buildings. If there's no water in buildings for a period of more than every 2 hours, you have a cholera epidemic. Who would think a cholera epidemic in New York City? I mean, like, this is just kind of. But if anybody has an idea of how you could defend against this, let me know. And you could make a lot of money with power companies. Anybody else? Yes? How can you utilize? Neutralize. Okay. That's again how do you defend against it? I don't know. But you got to realize the United States is looking to, and they have actually an EMP group that is trying to defend the United States against an EMP attack, electromagnetic pulse attack. And I think it was Edward Teller, who was one of the nuclear physicists, he theorized that if you set off an H-bomb, I think about 400 kilometers above Omaha, Nebraska, you'll create a pulse that will wipe out all the electronic control systems in the United States. Well, this is sort of a cheap system to wipe out the grid. I mean, you don't need a hydrogen bomb. You don't have to steal anything. You just need about $50,000, $60,000 and other people who are going to work with you. And it's tremendously asymmetrical. And again, there is historical basis for it, but nobody's ever thought of it before. I mean, the people that I've spoken to who do have advanced degrees and they're familiar with physics, electrical engineering, they said, wow, I wonder why nobody thought of that before. And if somebody has a degree and they say, this is just bullshit what I'm saying, I mean, you could rise up, tell me now. Yes? Sorry. I would say more than a millionfold. Because, first of all, a hydrogen bomb is a very powerful source, but its power is going off as 1 over r squared. It's decreasing very rapidly as distance. I'm injecting into electrical cable that's a conductor. So it doesn't decrease, it doesn't attenuate. According to the mixed, actually the inductance, capacitance, resistance clumping of the wire, and it dissipates much more slowly. But you're probably talking an order of magnitude over 1 million, probably far larger than that. Excuse me? Sorry.
Did that explain what the telephone wires? The wires one that is glowing red hot when they set off these
It may explain it at the pulses. But again, I'm not doing it through air. If you do the pulse through air, you need a hydrogen bomb. I'm doing it on the cheap. I'm doing it through an electrical system that already exists that basically is not protected from this type of attack. And as I said, it's tremendously asymmetrical. The feedback I got is, why didn't anybody ever think of that before? Anyone else? Okay, I'm running out of time. Sorry about that.